Hello and welcome. My name is Kapesa Ongiri Vincent, and we are going to look at support and movement in plants and animals. Meaning of support and movement. Support refers to the ability of organisms to bear their weight and to maintain their body forms. Now, living organisms require a firm and rigid structure. Living organisms require a firm and rigid structure to hold their bodies in place. They require a firm and rigid structure, and that is to hold their bodies in place. Support systems in all organisms, both plants and animals, are very important because they prevent organisms from collapsing and also to allow movement. Movement refers to the change in position of the body of an organism in response to a stimuli. Movement refers to a change in position of the organism in response to stimuli, and this stimuli can either be internal or external. It can either be internal stimuli or external stimuli. Now, movement of the whole organism is termed as locomotion. When the whole organism moves, we refer that to as locomotion. Now, while movement is characteristic of all organisms, locomotion is characteristic of only animals. Now, as in this case, there is this organism, that is the cheetah, is chasing the antelope, and the antelope is the prey that has to run so fast, so as to avoid the hunter, that is the cheetah. This is a kind of locomotion, and it is a characteristic of all animals. Now, support and movement in plants. Now, plants do not exhibit movement of the entire organism. Plants do not exhibit movement of the entire organism, but it involves movement of individual. It involves movement of individual organs. Now, the individual organs, as in this photograph, could be the shoots. And this shoot here is bending towards a source of light. So the stimuli that is allowing this kind of movement is light now, and so plants are moving towards light so that they can trap enough solar energy to drive it through the process of photosynthesis. Now, plants show growth movements. Plants show the kind of movement we refer to as growth movement in response to various stimuli, and the various stimuli in this case can be light, as in this case, it can be light, it can be gravity, as in the case of the roots that grows towards the center of gravity. It can be in response to touch, as in the case of Mimosa pudica, a plant that responds to touch. It can be also in response to water. We call it hydrotropism. So plants also respond to water, especially the roots. The roots of plants can respond to water. They grow towards a source of water. Now, support in plants is made possible. It's made possible by, number one, the turgidity of cells, and by the use of specialized tissues. They use turgidity of cells and the use of specialized tissues. Now, the specialized tissues in plants that are involved in support include the parenchyma tissues, the parenchyma tissues, these parenchyma tissues are called parenchyma tissues. Of course, we can also talk about the xylem, vessels, and tracheids. Importance of support and movement in plants. Plants require support and movement for various reasons. Number one, in insectivorous plants, movement of the leaves of the insectivorous plants allows them to trap insects and then digest the insects, and of course this becomes a source of nutrition. Number two, plants require support and movement to enable them to be held upright so as to trap maximum light for photosynthesis. Now, during gaseous exchange in plants, the movements of the guard cells, in response to either gaining or loss of water allows the stomata to open, and this enables gaseous exchange. This enables gaseous exchange. Of course, there are other issues as far as the importance of support and movement in plants is concerned, like holding of flowers in position for pollination, course, holding of the fruits and seeds in position for dispersal, movement of gametes, the movement of gametes to effect fertilization, and this of course ensures that there is perpetuation of generations in plants. And also, because of support and movement, plants are able to grow to heights and also to withstand the forces of the environment like gravity and the strong winds. The role of the stem in plant support. Now we ask ourselves that what is the role of the stem in plant support? Now, a stem plays a very important role in support in a plant. This is possible because of the presence of support tissues which provide mechanical support. Now we have tissues for support in plants that are located in the stems, and these tissues are the ones that provide mechanical support to the plants. Now, support tissues differ in various ways. Now, because of the support tissues that differ, then we have two types of stems, that is the herbaceous plants and of course the woody plants. Now the herbaceous plants have herbaceous stems and the woody plants have woody stems. Now herbaceous plants have soft and weak stems. The stems of herbaceous plants are soft and weak, and so the strength of these plants is derived from the turgidity of their cells. Now, the cells that take in water to become turgid so that they are able to support the herbaceous plants are mostly found in the parenchyma, tissues. And the parenchyma tissues, of course, are involved in support because they store storage to water. Of course, when absent in the herbaceous tissues, when water is absent in these parenchyma tissues, the cells become soft and the stems are weak. When the cells draw in water, they become turgid and the stems are strong. Woody stems. The woody stems have stiff, thickened and lignified walls. The woody stems have stiff, thickened and lignified walls, and because of this, these tissues with lignified walls are referred to as strengthening tissues, or sometimes we call them support tissues. Now, herbaceous plants like this one will drive their strength through absorption of water, and when this plant here have their cells absorbing water or drawing in water, their cells becomes turgid. Turgid is like that, where we say hard, and because of that the plants will get support. Now, if this plant loses water, the plant will wilt. And after the plant wilts, of course this is because of the cells losing water and then becoming soft. Climbing plants. Now, climbing plants have weak stems. They have weak stems, and because of their weak stems, of course, support is enhanced by a number of means. Now, one, these plants twine, or this twining of the plants, twining of plants around the stems of other plants for support. Number one. Number two, the use of tendrils, as in this case, the use of tendrils, where tendrils are the structures that are extended from, as in this case, they are structures extended from the leaf axis, and these tendrils are sensitive to touch. When they come across other plants, they twine around them, and this enables support for the climbing plants with weak stems. Now, of course, the climbing plants, in fact, some of them have thorns and spines. They have thorns and spines, and these thorns and spines are found in on their leaves or their stems to assist the plants to cling to other plants. So this assists the plants that, of course, possesses them to cling to cling to other plants or structures. This clinging, of course, is what will enhance their supports. Now let's discuss the hoodie plants in details now. Now we already talked about the hoodie plants, and hoodie plants have got special cells that we refer to as specialized tissues that will enhance support. Now these tissues involves the parenchyma tissues, and these parenchyma tissues are tightly packed tissues, and they are fully packed for storage and support. These tissues are found in the cortex. They are found in the cortex and pith. Number 2 is the parenchyma, and parenchyma tissues are tissues with living protoplasm and whose walls are thickened at the corners with cellulose. So the walls of their cells are thickened with cellulose. Now this thickening is what will enable them to over support. Of course, these ones are found beneath the epidermis. The one below, they are found below or beneath the epidermis. Now number 3 is the sclerenchyma tissues, and these tissues have rignified walls, and these lignified walls, of course, are thickened by the lignin. Now the sclerenchyma cells are found in the fascicula. They're found in the fascicular pandules, and they are, of course, dead cells. Now the sclerenchyma together with the parenchyma tissues form the hoodie part of the plant. This one, sclerenchyma, and parenchyma form the hoodie part of the plant. Now this xylem, vessels and tracheids. Our next point of discussion is the xylem, vessels and the tracheids. And xylem vessels have thick-walled tubes. These are thick-walled tubes. That have lignin, that are lignified. Now this lignin is what offers support. Of course, we have a number of different depositions of lignin on these tubular structures, like the annular thickening. Of course, you have to draw. Not very good in drawing, but I can attempt to have a drawing. Just straight this. These are the depositions, or anything like that. This gives us annular. Of course, we have others like spiral. Of course, I'm going to try to draw spiral. Of course, these are the different rectifications like this. This spiral. Of course, we have others like the pithed reckoning, like that. They're like pits. The depositions are like pits. Of course, we have others like reticular thickening, among others. Now, the tracheids have long cells with tapered ends. These ones have long cells, of course, with tapered ends. And of course, these cells are composed of dead cells to strengthen and support the plants. Now, the woody stems of their wood mainly made up of the xylem. Of course, you have to really draw. You have to really draw this tracheid. Not very good in drawing. Not very good. Not very good in drawing, because they have perforations on their walls. They have perforations on their walls, and we say that's why they are not very good in transport of water. So these tissues here have perforated walls, and these perforated walls make it have powdered pits. And I've already said that that's why they are not very efficient in transport of water. So that is the end of our lesson today. Thank you for listening.